More lamps arrived from China this morning, and you know what? I chose these ones because I thought they looked quite stylish. And they are. They are really stylish for Chinese, just typical eBay lamps. So I got one of each style, and I've tried them. They're certainly very bright. And the power rating was, as usual, giving us 3 watts. But when I plugged them in, they are indeed 3 watts. They draw either 3 or 3.1 watts. That's quite surprising. So I'm wondering how these are actually held together. I don't know if this is actually moulded together, the grey onto the white, or if it's actually a separate part. You can see a little bit of movement there. Ah. Okay. A ring of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 LEDs. So if it is actually, just assuming it's 100% efficient, which it's not, 3 watts divided by 18 equals about 160 milliwatts per LED, which is reasonable enough because they're not small LEDs, they're quite chunky. And it's held on by screws, which is nicer. It's quite a lot of power to be dissipated in such a small area. And this one's the biggest of them. So let's undo these screws. So I don't know if this plastic is thermally conductive. It's certainly they're mounted onto an aluminium plate, and it's on the plastic, but it's not got any thermal coupling to the plastic. I can see the circuitry through there, probably a capacitive dropper, but I'm not going to get that circuitry through there. Ah, now this comes out. Ah, it's a capacitive dropper. So quite a neat little capacitive dropper. There's a bridge rectifier. There's a little discharge resistor. There's the electrolytic, which is 4.7 megafarad, 400 volt. The capacitor is that 820? I think it's 820 nano. And really, I think there's a little inrush limiting resistor there, possibly 2 inrush limiting resistors. That one actually can't quite get the circuit board out. Yeah, I think there are 2. Going through the capacitor, then through the rectifier. To the electrolytic, and then there is a series resistor on the output to the LEDs. So pretty typical, really. So let's see how the other ones compare. This one was supposed to be warm white. It came through cold white. You can immediately see the difference. Very similar layout of chips. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 18 chips again. Whoop. I'm guessing these may have the same circuit board in all of them, although I'm not sure it's going to fit in that wee tiny one. Same circuit board, actually coming out a wee bit further. Ah, that resistor there, this one is a inrush limiting resistor, which is actually a 0 ohm link by the look of it. This one is a discharge resistor. Tiny print, could be 470k, not 100% sure. But the same as the other one. These are neat little lamps. Let's pop this one and see if it's any different. Let's see if I can get this in. I don't want to damage these because I quite like them actually. they're quite stylish, but I don't know how the thermal dissipation is going to hold up. If they get too warm, I may use the thermal imager on them and just see what sort of temperature they get up to. And if they get too warm, I may just make a tiny modification to them and change the value of the current limited capacitor, the series capacitor. Different layout. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 LEDs. Oh, the wire is quite tight in this one. I don't know if I'm going to get that out. No, I'm not. I may actually have to desolder that one to get it open. So if that's the case, you know, that circuit board probably would fit in there, unless it's a slightly thinner one. I'll leave a note. I'll desolder this and I'll leave a note, because the soldering iron's not hot, otherwise I'd do it right now. But oh, actually, you know, I think it is different. Yeah, it's a different circuit board, so yes. Yeah, I'm going to have to take this off now, aren't I, just to see what it is. But yeah, they're nice little lights. I quite like them. I think they're very stylish. I wonder if this is a thermally conductive plastic or not. Dunno. Because certainly if this one's dissipating the best parts of 3 watts, let's plug that in and check. So I'll get the power meter here. I have to turn that round. Oh, this is getting a wee bit cluttered here. As things do. And I'll plug this in. This has got a 2 watt Philips lamp in, 1.9 watt. Here's a little adapter. And let's screw this in. Yeah, drawing the best part of 3 watt. Oh, look how bright that is. Oh, slightly shimmery. Not too bad though. Oh, maybe it is. Yeah. I wonder how hot that's going to get. I shall meter that. And likewise, these units all draw in the sort of same area of power. I shall just... I'm going to plug this in. I'll screw this on first because it's got a gangly circuit board dangling around finger area. And it's drawing 3 watts spot on. Slightly less flicker in that one. Oh, it's still visible. Maybe the camera's just picking that up because it's quite bright and it's a fast shutter speed. It doesn't look flickery. Hold on till I do the finger test. Oh, there's a very slight ripple from the finger test. Much more prominent in the camera than it is to my eye. But yeah, they're nice lights. I quite like those. But definitely if they are running hot, I'll change that capacitor from the 820 nano down to something like 470 nano, just to cut the dissipation dramatically. It'll reduce the light output a lot, but from previous tests with underrunning and LEDs, it won't reduce it by half. It'll reduce it a modest amount, but it'll certainly cut the thermal dissipation down. Yeah, that's quite nice. I like those.